Hello and welcome to this session of NICER 201, online course on causal inference from observational studies, causal. We're talking about the topic on causal modeling in observational studies. And this is the second part of topic where I will talk to you about the differences between predictive and causal modeling and give you certain practical tips on how to do causal modeling. If we look at the two models, the causal modeling is causal in nature compared to predictive modeling, which is essentially non-causal. And hence, the goal of causal modeling is to determine the causal effect of the exposure on the outcome vis-a-vis predictive modeling, where the goal is to predict the occurrence of an outcome based on a set of variables. And hence, the appropriate research question that causal modeling addresses is, can the exposure be the cause of the outcome after addressing confounding? Whereas predictive modeling answers the question, given other covariates, will the outcome? So the approach differs between predictive modeling and causal modeling. In predictive modeling, we are basically concerned about the goodness of fit of the model and make sure that our model is parsimonious, which means we are using the minimum set of covariates to get the best fit model for the predictive modeling. However, the approach in causal modeling is different. We want to control for confounding using the minimum set of covariates or confounders. Now, in order to do that, we need to select variables for our multivariable regression. Again, in predictive modeling, we would first check for multicollinearity. And then we would look for a set of minimum number of covariates that can explain the maximum covariance in the model. However, in causal modeling, after checking for multicollinearity, what we would be looking for is a set of covariates that are sufficient enough to control for confounding a relationship between the exposure and the outcome. And hence, the expected output from a causal model is to get an unbiased estimate of the causal association between the exposure and the outcome, compared to predictive modeling, where the output expected is a precise estimate of the probability of the outcome. Remember that in order to identify causal effects from observational data, we have to make certain assumptions. In fact, in order to, even for randomized trials, we need to make these assumptions, which includes assumption of conditional exchangeability and that there is no unmeasured confounding given the measured variable. However, it is seen that it is nearly impossible to actually verify these two assumptions in observational studies compared to, say, the ideal randomized experiments where these assumptions would hold. And hence, we need to be very careful when we are trying to estimate the causal effect from observational studies. We need to make sure that we are addressing confounding. We are looking into whether there is a possibility of selection bias or a possibility of information or misclassification bias in our study before we come to the conclusion that a particular exposure or a particular covariate is causally related to the outcome of interest. If you look at literature, there are multiple approaches apart to look into, to go into in depth in terms of identifying these causal relationships using observational data and observational studies. Although we will not be going into detail of each one of them here, which is beyond the scope of this course, but just to emphasize that although mathematically and statistically, we need to be really careful when we are analyzing observational data, and it is possible to, in fact, estimate causal effects from observational studies if we are careful in terms of how we analyze the data and how we interpret the data in light of not just the random errors, but also the systematic errors or biases. Thank you.